Yeah. Is it okay, sir, now? Is it
Yes,
okay?
ma'am. Yes, ma'am.
So before getting into the session, so since today is our deep learning topic, I just wanted to let you know, like, what is this? Can you answer for this question? Who is driving this car? Who is driving this car? Participants, you can able to unmute yourself and talk, right? Or you put it in chat box. Let them talk or not, sir?
They can give in the chat box, ma'am.
Yeah, you can provide the answer in chat box.
Yeah. Access is there,
Who is,
madam, already.
yeah, okay, thank you, sir. Who is driving this car, ma? It's a small car, no one is driving. Even for small car, somebody needs, right? For driving. Yeah, good. No one. So it is very transparent that no one is driving this car, right? But actually, what technology is driving this car on the road? Which technology is driving the car on the road? Yes. And you would have heard about the recent model, right? What is a model? They provide self-driving cars, or driverless car, or smart cars, whatever you say. What is the name of the car? And what is the technology behind it? Yes. Yes. Yeah, absolutely. It is about deep learning. Deep learning is driving the car. That means we just incorporate the technology of deep learning. I'll just come to explain you about what is deep learning all about. And you just look at this picture. There is no one in the driving seat, and the car is moving smoothly, right? And some of you would have experienced the simulation part of this car, right? And today's topic is about how this deep learning is actually working. And before getting into that, what is deep learning all about? And whether deep learning and machine learning or neural network or artificial intelligence, all those are very, very similar, or is there any differences in that? We'll move on to that. Yeah. And one more question from me. What is this? I hope all of you would have been very, very familiar with this screen, right? Can you answer? Can you answer? Can you put it in chat box? Yes. What is this? What is this about? Google Lens. Yeah, exactly. As a student, you must know about it, right? During online classes, we people as a faculty, we used to give a lot of assignments, test, and we will be getting the answers immediately. I'm not blaming everybody, but just thanks to this Google Lens technology, whatever assignments we are giving as a picture, you can just translate that into the original text, original document, and you can just manipulate that, right? It is one of the applications of our Google Lens. And what about this? This is also one of the applications of our deep learning only. It is suppose if I want any accessories, any materials I wanted to do, I mean purchase, I never want to go to the shop and bargain something like that. I just pick up the picture of that. Suppose if I am very, very jealous about my friend's dress, I just take a picture of that and I just Google it. I'll be getting the cost and where I can grab the corresponding product. So I don't want to move out of my place, right? And these are all some of the basic applications behind our deep learning technologies. Okay, and you can just translate also. Suppose if you do not know Hindi or if you do not know other languages, you just take the picture of that and you can immediately translate that whatever language you know. Now, today's topic will be going inside about what is all about deep learning and why should we go for this deep learning? And definitely, whatever applications you have, you will be having some drawbacks also. What are they? And what are the examples of deep learning, and whether deep learning as well as machine learning are both same or any differences are there? How does this deep learning technology actually work? Then some of the topmost algorithms used for deep learning applications, and at last I will show you some demonstration on how our real-time applications work. Okay. And as I told you, deep learning is nothing but in any answers. Deep learning, any definition for deep learning, or any one word answer for deep learning? Simple. Automatic Tesla car. Yes, good. I am getting a lot of responses. I'm very happy to hear, because we are moved to physical mode. After a long time, I am just again coming into the online mode, right? So someone is controlling in hidden mode. Yes, exactly. Yeah, machine learning based on artificial neural network, subset of ML, exactly, subset of machine level languages. The thing is, nowadays, what we people are we have become very busy in training the machines like human being. And can you ever realize that we are gradually like degrading ourselves as a human? Have you ever realized that? Most of the time we don't want to reply to the persons, or we just obey like whatever machines is saying. Even if you go for online transactions, it will be asking you like, are you yeah, really you are not a robot, right? So put your captcha. But for the machine, we are replying that no, I am a human being. I am not at all a robot. I just put the captcha to justify that I am a human being, right? In this manner only, we have trained the human. I mean, we have trained the machine to verify that we people are human, and we are just proving to the machines. Earlier, we have the syllabus called human-computer interaction. Human will be interacting with the computer. Nowadays, computer is interacting with the human. Maybe after 2 to 3 years, our syllabus may be changed into CHI, that is computer to human interaction. Computer will be asking us, nowadays we almost everything has become autonomous, uh, atomic, right? That is automatic. So everything for we become very lazy, and we just depend upon the machine for all the needs we acquire, right? And here deep learning is very similar to your, as you told, like simplification of machine level language. It is not simplification like that. Earlier we have I just start with a data. Whenever you would come across a database management system or information management system, or you deal with a computer system, normally the teachers will be giving you what is a data. What is a data? What is a data? What is a data? I'll just give you a deep, I mean, brief intro about that. What is artificial intelligence? What is a data? I need a quick answer. What is the data? Data is nothing but, what is the data? I'm just getting into that bottom-up approach. What is it? Yeah, collection of similar information, but it is not a collection of similar information. Then what is an information? What is an information? Collection of objects? No, it's not collection of objects also. Data. Say for example, is if I say class, do you agree that the class is a data? Do you agree with me? Class is a data. Or sun. If I say sun is a SUN. Sun is a data, isn't it? But if I simply say class, I cannot interpret what I mean. I mean that the class may be a first class movie ticket, or a first class railway ticket, or first class people, or first class students, okay, or first class objects, or first rank in the class, isn't it? The first or the class may be meaningful in different perceptions, right? So a data is nothing but a truth. That's it. Sun sets in the like morning. I mean sun rises in the morning and sets in the evening, right? This is a truth about the sun, right? So sun, if I mean that sun is a true object, right? And how do I interpret the meaning of that? That is called as an information. From data, collection of data is nothing but information. Yes, I got the exact answer from this chat box. So I have a data. I just say class. So if I interpret like he belongs to first class, then I got a meaning. That is nothing but information, right? So data, from data, I am getting into meaningful statement called as information. And from information, I am gathering some knowledge. And you all know that for all the 100 students, we are teaching the same portion, and the timing is the same, and the exam question paper is the same, but the grade is different. Why so? How they are interpreting that information, whatever they are acquiring, how they are manipulating that in the exam hall, that is nothing but their knowledge, right? And what about intelligence? How they can just make more, we can say that the first toppers are more intelligent with respect to the grades whatever they are getting, but practically they may be higher than the people what they are getting in the theory papers, right? So intelligence is how they are interpreting what they are acquiring. And artificial intelligence is we are making the machine to think artificially. right? Instead of human being, the machines will be thinking on behalf of the human. That is nothing but your artificial intelligence. Or earlier we used to call it as an expert system. We call that he's an expert in uh, data science or machine language or IoT, something like that, right? So earlier we used to say the words like expert systems, artificial intelligence. After that, we have come across the ML, machine learning or machine language. So what we did is we just feed some input to the machine. Let the decision be taken by the machine itself. I just keep on giving so many inputs. So the machine itself will be able to give the decision, the correct decisions based on the input, whatever I have given. And now deep learning, and deep learning is subset of your machine learning. In deep learning, instead of giving a small inputs, I will be giving large number of inputs, so that the accuracy level will be very, very high. As all of us know that information is wealth, isn't it? Information is wealth. That means what? How much information you are providing to the system, that much accurate your output will be, that much clear cut outcome you will be getting from the machine. That's what we deal with our deep learning. We are just making the machine to mimic the same way what we do. What, as a human being, whatever we are doing, we just make the machines to do the similar work. That's what we do with our deep learning. And now we will just move to the next one. Yeah, always we used to say that deep learning is a very enjoyable thing to read on. And as I told you, some of the applications of deep learning will be self-driving cars, visual assistants. I hope all of you will be having iOS devices, right? Siri, Alexa, and all. And that you just, even though you forget some of the moments, it will just remind you to activate that, right? And yeah, what actually this deep learning is, deep learning, we know like it is a subset of machine language or machine learning, and it is using neural network. As we people, human being, are using our brains, this deep learning is using the is using the neural network concept, which contains several layers of nodes. I will just elaborate with an real-time example now. And you will normally in school days or even in our first year, what is a computer? This is a common question everybody will ask. What is a computer? What are the parts of the computer? What you say? What are the parts of a computer? Input device, output device, in between CPU or central processing unit. That's it. Our entire computer is defined only with the three parts, right? Input, output, processing thing. That's it. So in the same manner, I am just going to give some input. I will be retrieving some output. In between, I'll be just feeding some weights or some biases, and via this hidden layers, I'll be just uh, providing so many layers to get the output into more accurate level. That's what it's very, very simple. In our normal neural network, uh, look at this. This is a general neural network. I'm just giving so many inputs. Say, for example, I'm just giving a cat, a dog, and some other rat, something like that. And I just wanted to classify whether the input is as a cat or dog. Okay. So based on that, I am going to get the output. I want the exact output. But sometimes it may be getting confused. Nowadays, you can see that so many dogs are similar to cat, right? Their breed or something like that. So I just don't want the more or less output. I want the exact output. What I do is I just keep on adding the weights in between the input and the output layers, that we call it as a hidden layers. I'll be having so many hidden layers. In a neural network, only one layer will be there, but in terms of deep learning, you may be having more than two layers. Maximum, as much as possible, you just keep on adding it to get into the reduction of the loss function, and to get into the more accurate level of your output layers. That, and why should we go for this deep learning is to process huge amount of data, and to simplify the complex algorithms into very, very meaningful matter, right? And the feature extraction, whatever object I give, I just get the exact output what I acquire. And normally, when you go ahead with anything, you will be having some drawbacks also. Here, we can just neglect the drawback if it is the ratio is very, very small, right? And here, the lack of transparency in fault revision. Normally, when you search with the Google, suppose if I want to acquire some information, I just type some word in the Google. What I do is, I always believe in Google. I always believe in whatever information I'm getting from the Google, right? But all the informations may not be the correct. I may get some fake news, or I may get some wrong information. Maybe the source would have not verified the news feed they have posted, right? But I believe in Google, whatever information I am just getting, I just, okay, this is what I want. I just stop with that. But there should be some fault tolerance information needed. And GPU cost is very much higher, but we don't bother about it because we need the automated the process in a faster way. So we just neglect all these disadvantages. And this we have seen artificial intelligence. Under that, we have the machine learning, and then under that, deep learning. And this also, I just informed you, this is a very simple layer in our neural network. But in terms of deep neural network, we'll be having so many hidden layers. And what is that hidden layer, ma'am? Every time we learn about this NN, we are just discussing about these things. Let me take a simple example. I'm just giving some input, okay, in terms of x1, x2 till some n number of inputs I have, and for each and everything I'll be having some weightage, right? I just multiply this x into w and giving into the neurons. Okay, I'll be just giving some bias value also to get the proper output. I'll just show you how exactly this works. Okay, look at this, our brain structure, dendrites. Look at this brain structure. We have the similar structure only we are following, right? We have the dendrites, and then your output will be the signals what we are giving out, right? And all these are input dendrites. I'm just giving the input signals. You'll be having a cell body and axons. This is the output line, and this node is nothing but the nucleus. Okay, axons are your outputs. It is very, very similar. All of you would have searched about the brain detox, right? We may be having multiple informations in our brain. Nowadays, people are going for a treatment of brain detox, like removing some garbage input from our brains, right? And also cognitive technology. You just keep on recalling whatever you have learned earlier. Suppose if you remember everything, every person will be getting 100 marks, right? Once you learn something from pre-KG, if you keep on remembering till your graduation level, you just imagine that how much information you know. If you never forget anything, it's not at all possible, right? This is what we are just having that brain detox and all. And dendrites, you'll be feeding that input, and your neurons will be there. Then you'll be just getting the output, and you will feed some activation function to get more accurate level. That's what the very, very similar structure of this. And you can simulate that with our in NN. And look at that, I'm just feeding that with the weightage of that input, corresponding weight, and what is the input level I'm just giving to that summation function with the bias value, some bias value. Sometimes I may give or may not give any inputs, so I'll be just giving some bias value or threshold level. Okay. And here using the sigmoidal function, I can like measure the accuracy level of it. I'll just give you one more simple example of that. Very, very, very small image is there, right? I have a bird picture, and here I just wanted to find out the beak. Okay, beak is a very, very small parameter. How do I find it? I just put some input over here and weightage of all the inputs, and I'll be just putting that into the activation function. Look at that, beak is there, and I just wanted to identify whether beak is there inside the picture or not. That is my target. Okay, and here there are this beak is somewhat visible over here in that left topmost corner. It is there, but look at this here. This is what we call it's a localization. Apart from finding that image, we are going to find out where it actually lies. That we call it as a localization. It is in the middle and it is in the left upper corner. Okay, so you need to find wherever it is. I just want to get the beak of a bird. Okay, and what I do is I just feed on the input to the convolution layers, and I just apply some filter. You may be asking what is a filter, ma'am. I just give us. Are you following? If you know this, I can skip this. I can go get into the real world applications. I just give. Is that okay? Is that okay? Can I give you these filter functions? Can I? Or I will skip this. We'll just move into the yes. Yeah, good. Yes means what? I can don't skip. Yeah, thank you, ma. Because yes means in two ways I can take it out. So actually, it's I just want to make this concept very, 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 very simple. Everybody will be talking about a filter. Actually, what is that filter? We know coffee filter, right? But what is this filter all about? I have a picture, right? But the computer will never recognize whether you are speaking something, whether you are inputting, texting something, whether you are giving some image, video. It doesn't recognize anything, right? So it will be converting every information into binary numbers. Look at this. I have some convolution layer like this. I just give the input like this. Okay, some random input you take it on, and I am going to apply the filter. Filter means what? What I need is I want it. So you know very well, if I apply AND gate over here for this, should I write over here? Okay, look at this. So this diagonal is having 1, 1, 1. You just take only this square matrix. Okay, 3 by 3 square matrix alone, right? This one. So I just have two filters. One in the diagonal side, all ones. In the second column, all ones. The two filter I'm going to apply. That means only these values I can take it into account. The remaining value I will be in a negative. That is, I may not take it into account. It is something like a color matching. I have some red color. I just want the same red color saree in the shop. So I just match with whatever material I have, right? The same thing. I just apply the filter to get the actual output what I need. And look at this, 6 by 6 image is there, but I have 3 by 3 filters, two filters I have. What I do is, likewise, I may be having multiple number of filters, right? And every filter deducts a small pattern of 3 by 3. What we are going to do is, instead of processing this 6 by 6 image, I am going to reduce the dimensionality of this entire diagram. Okay, and you just make the dot product of this. You first take 3 by 3 square matrix along with this filter one, give a dot product. Dot product means what? AND operations. So what happens? 1 into 1, then this 1 into 1, this 1 into 1, right? So what may be your answer? 3. The rest all 0 only. Now 0 into anything, it will become 0 only. So only this value I'll be getting, and add it, you'll be getting 3. Is this clear? And next, what you have to do? Slide by slide, stride. We call this as a stride. Stride by stride, you have to apply this filter. This is called as a stride. Are you able to see this? So next stride, I have some other parameters. You apply the filter. What you will be getting? This side here, I am just getting 1. So 1 into 1 is, this is minus 1, right? So minus 1, my plus 1, then plus 1, isn't it? So what is the answer? Can you tell me what will be the answer for this? Yes, make it fast. I have this matrix and multiply this with it. You can neglect all the zeros, right? Only one is active. So 1 into minus 1, then minus 1 into 1, so minus 1. What? Then 1. What may be the answer? Quick, quick. We don't have time. Quick. Are you putting in chat box? I don't get it. What is the answer? Yeah, exactly. Minus 1. Good. So likewise, next stride. Stride 3. Likewise, you just move on. You will be getting 4 answers, right? And you just make that 4 by 4 matrix. Okay, you got this. For applying filter 1. Likewise, you just apply second filter also. And here, look at that. What are the positive answers you get? That alone is matching with your thing. And repeat this for each and every filter. You just, this is what we are doing with our hidden layers. Just keep on repeating these filtering operations for all the vectors. Okay, and you will be getting the feature map, and the 4 by 4 feature map 2 times you are getting, since we have applied 2 filters now, so 2 into 4 into 4, 4 by 4 matrix is output, and 2 times I have done with the 2 filters, so I'll be getting the dimension with 2 into 4 into 4 matrices. Okay, likewise for all your matching operations, you will be applying this filter, you get the factor, vector value like this. Okay, this is what we do. You just apply that to your fully connected neural network. That's what. Okay, and the 6 by 6 matrix will be reduced into, look at this. I'm just applying first filter, and only 9 outputs are there, and it's not connected. You just apply another, you just keep on doing that. This is the overall view about your CNN. You just take the image and convert that image into matrix format. Okay, that vectoring, and then apply it to the convolution we get. And the max pooling is what we have done now. Okay, you just apply the filter and again repeat it for many times, again apply the filter, just keep on doing it. You will be getting what, whether it is a cat or dog, you will be getting the classification prediction. That's it. Okay, this is what we call as a max pooling. I'll just skip all these things. If you want, I will just share you this. And look at this. Earlier I had a 6 by 6 matrix. Now I'm just converting this 4 by 4 matrix into again 3 by 3. The reduction will be very, very simple. Look at this. I have reduced somewhat. Yeah, 2 by 2. Okay, 4 by 4 matrix. Again, it has been divided. I think some of you would have come across this Strassen's matrix multiplication or divide and conquer method. We are dividing the entire matrix into small portions so that our multiplication will be very easier, isn't it? In similar manner, what I do was I just reduce the entire matrix into small portions. Okay. And now I'm just a subsampling. What is meant by subsampling is I have a larger image. What I do, I don't want that much bigger image. I just reduce the size of that. This is called as subsampling. Even though I am reducing the size of this, look at it clearly. I am not degrading the quality of the image. The quality of the image is very similar to the larger image. Okay, if that image is very smaller, that's it. But the quality of the image is not changed. Oh. So I am reducing into 2 by 2 matrix. That's it. Okay. And this is the exact functioning happening over here. So just keep all those things. I'll just share this PPT. We will the same process. You just keep on reducing the dimension. Okay. This is one of the gaming applications where it doesn't apply a deep neural network. It is having a 19 by 19 portions. AlphaGo. I hope all of you would have played with this game. AlphaGo. It is a feed-forward neural network. And a deep neural network is back propagation. You can apply back propagation. So you can just go back and feed the input to get the last function somewhat lesser. Okay. And does not use max pooling at all. AlphaGo. This is a simple working methodology behind our CNN. Okay. Excuse me. CNN in speech recognition. Okay. CNN in speech recognition. In a similar manner, everything will be converted into vectors. Okay. Now we will. This is for text classification. Yeah. So what is all about this? Suppose if I give an input as apple, I have to get that apple is a fruit. I should not get that apple iPhone or apple tab, something like that. Are you getting my point? This is what we call it as semantic visualization. Even though apple is a word, I may interpret in either it is a fruit or it as a iPad. Okay, so in deep learning, apart from giving the features of that, you can get the meaning also. You will be getting the labeling. Automated labeling also can be done with the help of deep learning neural network. Whether my voice is clear, this noise is disturbing you? Sir, is that okay? Is it okay? Whether noise is disturbing you or I will just move this. Is that okay? Whether my voice is okay? Is that okay, ma? Or you are okay? Thank you. So look at that. Yeah, the same manner. You just apply this input and you'll be getting it. I just skip. And look at this very interesting topic over here. I just give the input and the weightage of all the inputs. It is something like if you go to a grocery shop, what you do, you just buy 1 kg of tomato and what is the weight 1 kg and what is the price? You just multiply that, right? You just apply some bias function. That's it. So you will be getting the output the same manner. I am just giving the input along with the weightage of each and every input, and I just give the bias value or some threshold value. Okay, and I'll be getting the output. And look at this clearly. For these things, as I have only two inputs, x1 and x2, I'll be giving it as 0 and 1. For two binary numbers, I'll be getting 4 combinations, right? 0, 0, 0, 1, 1, 0, 1, 1. And you just apply this to this wx x w1 x1 and w2 x2. Just add it with along with x1 as 0, x2 as 0. For w1 as -2, w2 as -2. Likewise, you just apply for all these 4 combinations. You are getting some output. Either it is 1 or 0. I will be getting only 2 answers, right? Either I get 2 binary numbers as 1 or 0. And look at this. This is simulating NAND gate operations. So NAND gate means what? NAND gate, it is the opposite of AND gate, right? If all inputs are 1, I am getting 0. That means what? If I provide all these input, exactly I'm getting 0. This is simulating a NAND gate. Likewise, you just compare with which kind of gate operations you are getting as an output. Correspondingly, you can get the classification method. That's it. And likewise, this is a one simple example I have given you. Like, you just imagine that for our deep learning, you apply many layers and many activation functions like that. It will be something like mesh topology. I think in a computer networks, you would have heard about it, mesh topology. You will be having so many connections and you will be just feeding all the inputs and give the weightage and you will be getting the output of that. Okay. Look at this, so many hidden layers are there. Massive scale up of nodes, right? And now we will go into the interesting topic of types of machine learning algorithms. What are they? What are the 3 types of machine learning algorithms we have? What are the 3 types of machine learning algorithms we have? Can you hear my voice or shall I increase it? Yes. What are the 3 types of machine learning algorithms? Supervised, unsupervised, reinforcement. All of you know, right? Shall I skip this? Do you know this? Can anyone tell me what is supervised? With a simple example, can you tell me? Yes? Yeah, you know. Good, ma'am. Then I will just skip this. If you know the labeling, if you know very well, this is a dog, this is a cat, you just label that and feed it to the data set, then it will become a supervised. Unsupervised, you may not be knowing what category it is. You just cluster that, this what. You just label everything. This is a pawn, this is a soldier, something like that. You just get it as a supervised learning. Unsupervised, you do not know, but you are just comparing. This height is somewhat lower than this, and this shape is somewhat similar to that. So you just compare with the similarity of structure from other objects. You just identify what it may be. It may be only. And now we just get into the interesting topic. Actually, this is our main topic, right? Deep learning applications. As I already told you, some of our Alexa, Siri are assisting us to utilize our time very efficiently. But I do not know how many of us are efficiently utilizing our time. We are simply wasting our time, right? We do not use our brain to create something new. We just copy and paste wherever we just go, right? And You apply deep learning for face recognition, autonomous vehicle, and sound addiction to the silent films. These are some of the real-time applications of our deep learning applications. And look at that. You just see the picture, you can learn by yourself. Visual assistants, almost all of you would be having it. Translators, and we don't bother about why if this app is there with me, I never learn any new languages, isn't it? I never eager to learn any other new languages since I have the app. I just scan it and get the corresponding sentences. Why should I learn a new language? It is actually what degrading our skill set, isn't it? Even though we are saying that it is in the uh, pros level, but it is a con only. That is, it is a drawback only, isn't it? And look at that and for driverless delivery trucks, drones, and autonomous cars. Even nowadays, you have a Zepto. Within 10 minutes, you'll be getting the groceries. And Dunzo. So many apps have come for not moving us from outside of our house, isn't it? We just stay at the home and we just bother about obesity and that, isn't it? And chatbots and service bots. Chatbot and service bots. Earlier, when you call for any customer care, you need to put so many dial numbers, and one customer on BPO service will be like contacting with us and asking for the queries. But nowadays, nothing will happen like that. You just have automated chatbots. Whatever queries you input, they will give you the answers. So you get it instantly. Okay. And facial recognition. Even you just go inside the shop, just show your face, and your money will be debited, whatever item you are picking. And suppose if you again put it in the basket, the money will be added. Even you can just use a card, right? In like almost most of the supermarkets in other countries, they have implemented it to come in India. And healthcare, you can just recognize the diseases earlier, and you can reduce the death rate. Nowadays, we just during COVID time, we got this actual advantage. We could able to save multiple persons, right? And the personal is shopping and entertainment. I just live with our Netflix, Amazon, YouTube, Spotify, and all during this 2 years of period time, right? And here, whatever movie I like, next time when I switch on that, immediately I'll be just getting all the recommendation systems for the corresponding movies, whatever I have watched. And I just keep on sitting and watching the rest of the movies, okay, to waste my time actually. But I should not say like that. Okay, maybe to improvise your knowledge, right? And Spotify, you just relax your mind. And Spotify is also applying this deep learning on it. And new aggregations and the fake news reduction. As I told you, you just don't rely on whatever information you are getting through Google is correct. It is not. Google, you don't depend on the social media or the website, whatever you are getting. When you search in Google, whatever top ranking searches have done, based on that only it will giving you the reply. It is not like it is 100% not accurate. Okay? And you can make somewhat into accurate level by using these filtering operations and composing music. Suppose in the older movies, some of the movies are like they don't have dialogues, so you can just add the dialogues, and you can add some sounds, and you can just digitalize the older movies with the help of our deep learning technologies. And image coloring, if you have the grayscale images, you just apply the hidden layers and make into more colorful and interesting games. You have an application also, chroma gan. And robotics, you can just make even all of you are an Andhra, right? One movie recently they have released, Google Kuttappa. Have you heard about that? Whether it is released or yet to release. They are adapting one robo for helping an older person. And image captioning. Suppose if I just put an image, it will just give you the caption or label of that automatically. That's what I have told you in Apple. It may be a fruit or it may be iPad. It will just give you the label automatically. And advertisement, gaming. You have an AlphaGo game. Just now I have shown you that alpha game. Look at this. You can like play with the system with only with the 15 movements. You can just get the answers. And actually, I was very much impressed with this reinforcement learning. When maybe 7 years back, One IIT professor, he was discussing about the reinforcement learning with basketball, how accurately the player can predict the forcing of the ball and capturing that. Okay, so you can learn by sitting at your system itself, you can learn the strikes over there. Okay, and some more real-time applications of our deep learning are automatic colorization and game playing. Here, I have something on the system. I can easily convert that into some other text. I do not want to copy the same thing. I just convert that into some other meaningful format. And any new ideas you have come across now? We have discussed so many things, right? Can you please suggest some other new technologies? Every day we wonder that how these technologies are happening, and any one of you have missed out. Oh, I had this in my mind, but they have released it. I was very late to release that, or I was very late to explore that. Anybody is having in that mindset? Anybody is having in that mindset? Anybody? Anyone? Ma'am, I had that idea, but I couldn't able to implement it, but somebody has implemented it. I'll just make it a slideshow. Yeah. Any guesses or any innovations you got in your mind, but you couldn't able to implement it or shown to the public? If so, you please don't wait. You just apply for a pattern. You just talk to your peer group or talk to your teachers or your faculty advisors, and you just make that as a patent, or you just make that as a journal paper, so that your idea will be giving you some money also. You can just grant your patent and you can earn money from that. And even some of the incubation centers are there. You can just implement that idea, they will sponsor you, and you can learn by studying itself. You can learn more, you can learn and earn more. And future scope maybe in astronauts, or even you can just find the drops and measuring of the water when it is when any scarcity is there. And these are all similar applications. And now some of the top learning algorithms in deep learning. I hope all of you would have heard this, right? K nearest neighbor, ANN, CNN, recurrent neural network. CNN, I think on third day, one more resource person will be discussing in depth about CNN, recurrent neural network, deep neural network, deep belief network, back propagation. Deep learning accepts back propagation. That, suppose if you are not satisfied with the output what you have gathered, you can just feed some more input back to the layers, and you can just reduce the loss functions, okay, error functions. And some of the deep learning frameworks, and where TensorFlow have, from where TensorFlow have been released? TensorFlow is released by Google. Normally we people, unless you people are adapted to the current technology, nobody will seek about you. No, just you will become obsolete. It is something like you think like a product. Unless otherwise it is marketed, and unless otherwise it is exposed in the market, nobody will buy them. Same thing we people are in a state, right? You just explore whatever you have in your mind. Don't delay. In within a nanosecond, so many new products are coming into existence. So you just adapt to the technology and find some innovation, and you just make your name as a like patent for that. Okay. And now that's what I told you now. It's simply a horse, and you can have a creature on the horse like a race car, or even you can just build some other extra autonomous car like this. Okay. And have you ever heard about this nostalgia? Nostalgia? Yes. Any guesses on that? You could able to find our grandparents into like a live stage. I'll just show you that. Hope my screen is visible. Is it, sir? Is it visible? Is it visible? Any one of you, please answer me. Please answer me. Look at this. Have you ever seen this? Can you able to see my screen? Please reply back. I will just put in the chat box. Yes, ma. Thank you. And look at this. What is this about? Actually, even though you could be able to get smile on the uh, past persons, okay, you can just give life to them, at least in the videos. Okay, that's what about our nostalgia. And this is also one of the main applications of our deep learning, blink and smile. You can just make the historic photos into blink and smile mode. You just imagine that how you can able to like get them back, right? And yeah, this is the most interesting topic I wanted to discuss. What is this? What is this? What is this? What is this? What is this picture about? What is happening over here? What? Any guesses? Just check in the chat box. Image recognition, deduction. One framework is there. One framework called something like object identification. Good, great. Image recognition, object identification, deduction. All are correct. All are correct. Boys, you please keep silence, please. 5 minutes. Object rectification, image processing, object identification. Good. Have you ever heard about the concept of YOLO? YOLO. Yes. Let me show that. Yes. YOLO, you would have played with that YOLO game, right? So you only look once. Object deduction, real-time object deduction. What it means actually is almost all the answers what you have given is correct only. It identifies the object, it deducts the object, it predicts what is there in the street and all. Look at that. Here, I'll just give you a small session on this YOLO. If you want, you can just copy this. Shall I put it in chat box? You need this in chat box. Wait a moment. I'll just put this so that later also you can practice. Okay. Look at that. You just go to, yeah. Is the screen visible? The practical session on GitHub? Visible?
Yes, ma'am.
Okay, thank you. And look at this. Just they are just playing. What is happening over here is I can incorporate an image and I object deduction. This is something like multiple object deduction. Normally what we do, you find a cat, you find a dog, they will say like that, isn't it? But here it captures that entire atmosphere and how many persons are there, how many footballs are there, how many shoes are there, and even a pocket, and inside a pocket whether a pen is there. Even a small object can be identified with this YOLO concept. Now recently we have got YOLO version 3. So we could be able to identify all the objects. How it is happening is earlier we have seen that the stride na same concept. What here they are doing is a small SSD, small short deduction or multi-shot deduction. They will just make each and everything as a frame, just small frames they will just manipulate. And within that frame, any object is recognized or not. If it is not recognized, they will just leave that out. So they just put, okay, one human is there. So they are just making a frame. Here one more human and here one ball is there. So you can just make that and you can label it. And you can just make this label to say shoe. Likewise, using this application, what is that? Yeah, using this label MG, you just try by yourself. You download it from this site and you can just, I'll just show you how to download also. Okay. Okay. What is that? Yeah. So you just label whatever objects you are finding over here. You train that. Later on, when you feed it, it will automatically show you how many balls are there, how many shoes are there, who are all the persons, and everything you can able to identify. It's very, very simple application you can install, and just apply your mind and apply your own pictures and get to know how the classification is happening. I'll show you that. Okay. I'll, I'll just show you how to install it. You side by side you can allow install. Suppose if you have it, you just install it. If you have a laptop with you now, you can parallelly install it. Just go to this site. I hope you are seeing my, look at this. You have various versions. Yeah, either you can install it over Linux machine or Windows machine. You just take any versions, no problem. I'm just using Windows version and 1.4.3. Anything you can take it and install it. Yeah, so it will just give you a zip file. Extract this, or you can directly install it also, no problem. Just install it. Okay. Okay, this is what. Yeah. Oh, I removed it. I didn't extract it now, I just removed it. Anyway, any versions I just take. You can try with a number of objects over there. So you will be getting, yeah. Look at this. You just open a directory where you have a set of pictures or your data set where you have. I don't think that may or may not use the office system. Some sample pictures. Okay, I just take from here. Look at this. I have some number of pictures. This is default pictures, right? And here you just go to create rectangular box. What you can do, you can just make label it as a big, right? You can classify, you can just label whatever you want. Then you just label this as a feather, something like that. Okay, even though it cannot fly, I'm just giving it as a feather only, right? You are just classifying all these things, and for the next picture also you do like that. Okay, and save this, save the image. Okay, sample picture, save the image and verify the image also. Here you'll be getting verified image for the next images. You just label it, create a rectangular box. This is in orange color, you can just give it as orange. Likewise, you can just put all the labels, and it will just give you one more set of images. Here you have the images, it will just give you one more set of images, and if you just go and run here in your GitHub, you just change the coding according to your source images and the labels whatever you have gathered. I'll just show you that. Just install and upload it over here. This is a sample picture I have. Okay, and install it. Image path, you just give the corresponding image path. Where you have actually stored your data. This is for Docker they have given, and you just open the directory, create. They have given the steps also for creating this VOC. VOC is nothing but where you have classified the images, right? That file will be saved as a VOC. So you just open that corresponding folder, and you just install, incorporate corresponding directories over here. If you run that, you will be getting the corresponding classes. It is something like whether you have got the orange colors like this, you have got the orange colors, or how many balls you have. If you run that image, you can able to see whatever frames you have designed, it will be visible to you. This is a very basic concept behind your Yola. It's a very open source Yola. And one more thing also there. Traffic police normally what they do, if you don't wear the helmet, or if three persons are riding on the single bike, they will put fine, right? For them also it will be useful. They don't want to stand on the summer season and all on the roadside and all. The system will capture you. If you are riding with three people, the system will capture you and it will just make you fine. Nowadays everything has become automated. So you just work with these things. Don't read everything as a theoretical part. Just adapt with the real-time applications. Small things, you just do it. That's all about my session. I think it's almost time up. And even still, you have a lot of research going on under this. Normally, what you can do is you take a existing system and try to improvise accuracy level, or you try to improvise that more number of classes, or you cluster into more lengthier speed, and also you can just reduce the loss functions or error functions. You just if you could not find a innovative thing, you can just use the existing one and enhance that. Or if you really feel that I am more innovative guy, ma'am, I can able to design by myself, you just don't wait, you just put it in a paper itself. You just find a prototype of that. Okay. And thank you all. This is my contact mail ID. And thanks for your patience. Sorry, in between I was went offline. I couldn't able to like completely do that. And that's all, sir.